Underwriters Laboratories Incorporated, also known as UL, has issued a warning concerning the Etcon Incorporated Receptacle and Arc Fault Circuit Interrupter, abbreviated AFCI, circuit tester, specifically model AF120. This particular device presents a potential electric shock hazard primarily due to the unauthorized UL listing market bias and the inadequate safety features incorporated into its design. Furthermore, the tester may not accurately assess all types of AFCIs, which could lead to unreliable and potentially misleading test outcomes. It is crucial to understand the details of this warning to ensure electrical safety practices are maintained. The core issue stems from the fact that this specific product has not undergone evaluation by underwriters' laboratories, yet it displays an unauthorized UL listing mark. This mark typically indicates that a product has met UL rigorous safety standards, but in this case, that assurance is false. The absence of proper evaluation and the presence of a fraudulent mark raise significant concerns about the product's overall safety and reliability. The potential hazards associated with this AFCI circuit tester are twofold. Firstly, there is a risk of electric shock due to the inadequate safety features. Electrical testing equipment must be designed with multiple layers of protection to prevent users from coming into contact with live electrical components. If these safety measures are not properly implemented, users could be exposed to dangerous voltages, leading to severe injury or even death. Secondly, the tester may not accurately assess all types of AFCIs. AFCIs are designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. There are different types of AFCIs designed to detect various kinds of arc faults, and a reliable tester should be able to verify that each type of AFCI is functioning correctly. If the tester provides inaccurate results, it could create a false sense of security, leaving electrical systems vulnerable to undetected arc faults. Given these potential hazards, several recommendations are put forth to mitigate risks and ensure electrical safety. Firstly, it is strongly advised not to use the Etcon Incorporated Receptacle and AFCI circuit tester, model AF120. Remove it from service immediately and do not rely on it for any electrical testing purposes. Secondly, contact Etcon Incorporated directly at their customer service number, which is 800-433-8914 to inquire about the possibility of obtaining a refund or a replacement for the defective product. Thirdly, when performing AFCI circuit testing, always opt for UL-listed AFCI circuit tester. These testers have been evaluated by underwriters' laboratories and have met the required safety and performance standards, providing a higher degree of accuracy and reliability. To obtain more detailed information regarding this warning and the specific hazards associated with the Etcon Incorporated AFCI circuit tester, it is recommended to visit the UL website. The relevant page can be found at the provided URL, which is all.com/media/nr902402 HTML. The website offers additional insights, technical specifications, and potential consequences of using the non-compliant product. Understanding arc fault circuit interrupters is critical in appreciating the significance of this warning. AFCIs are designed to protect against fires caused by arc faults. An arc fault is an unintentional electrical discharge that occurs when electricity jumps between two conductors. This can happen when wires are damaged, insulation is worn, or connections are loose. Arc faults generate intense heat, which can ignite nearby flammable materials, leading to a fire. AFCIs work by monitoring the electrical current flowing through a circuit. They are designed to detect the unique characteristics of arc faults, such as irregular current patterns and high-frequency noise. When an AFCI detects an arc fault, it quickly trips the circuit, cutting off the flow of electricity and preventing a fire. There are two main types of AFCIs: branch and combination. Branch circuit AFCIs protect against arc faults in the branch circuit wiring, such as the wiring that runs from the circuit breaker to the outlets and lights in a room. Combination AFCIs provide both branch circuit protection and protection against arc faults in core connected appliances. Combination AFCIs are more sensitive and provide a higher level of protection than branch circuit AFCIs. The effectiveness of an AFCI depends on its ability to accurately detect arc faults and quickly trip the circuit. A faulty AFCI tester can compromise this protection by providing false readings or failing to detect actual arc faults. This is why it is essential to use a reliable, UL-listed AFCI tester to verify that AFCIs are functioning correctly. The UL listing mark is a widely recognized symbol of safety and quality. It indicates that a product has been tested and certified by underwriters' laboratories to meet specific safety standards. UL evaluates products for a wide range of hazards, including electric shock, fire, and mechanical hazards. When a product bears the UL listing mark, it provides assurance that the product has been thoroughly tested and meets the required safety standards. The presence of an unauthorized UL listing mark on the Etcon Incorporated AFCI circuit tester is a serious issue. It suggests that the manufacturer is falsely claiming that the product has been evaluated and certified by UL. This can mislead consumers into believing that the product is safe when it may not be. Furthermore, the unauthorized mark undermines the credibility of the UL listing mark and can erode consumer confidence in safety certifications. In addition to the potential hazards associated with the Etcon Incorporated AFCI circuit tester, there are also broader implications for electrical safety. The use of non-compliant electrical testing equipment can lead to inaccurate results, which can compromise the safety of electrical systems. For example, if a non-compliant AFCI tester fails to detect an arc fault, it could leave a circuit vulnerable to a fire. Similarly, if a non-compliant voltage tester provides inaccurate voltage readings, it could lead to electric shock. It is essential to use only compliant and properly calibrated electrical testing equipment to ensure accurate results and maintain electrical safety. Regular inspection and testing of electrical systems are crucial for preventing electrical hazards. Electrical systems should be inspected periodically by qualified electricians to identify potential problems such as damaged wiring, loose connections, and overloaded circuits. Electrical testing should also be performed regularly to verify that safety devices such as AFCIs and ground fault circuit interrupters, abbreviated GFCIs, are functioning correctly. By identifying and addressing potential problems early, it is possible to prevent electrical hazards and ensure the safety of buildings and occupants. In summary, the UL warning regarding the Etcon Incorporated AFCI circuit tester highlights the importance of using only compliant and reliable electrical testing equipment. The potential hazards associated with this tester, including electric shock and inaccurate AFCI testing, underscore the need for caution and diligence when selecting and using electrical testing tools. By following the recommendations provided, such as avoiding the use of the Etcon Incorporated tester and opting for UL-listed alternatives, it is possible to mitigate risks and maintain electrical safety. Furthermore, regular inspection and testing of electrical systems are essential for preventing electrical hazards and ensuring the safety of buildings and occupants. Remember, electrical safety is a shared responsibility. By staying informed about potential hazards and taking appropriate precautions, everyone can contribute to creating a safer electrical environment. When selecting an AFCI tester, consider the following factors. Firstly, ensure that the tester is UL listed, which means that it has been tested and certified by underwriters' laboratories to meet specific safety and performance standards. Secondly, choose a tester that is compatible with the types of AFCIs that you need to test. There are different types of AFCIs, and not all testers are compatible with all types. Thirdly, select a tester that is easy to use and provides clear and accurate results. A good tester should have a simple interface and provide readings that are easy to interpret. Fourthly, consider the price of the tester. AFCI testers range in price from a few dollars to several $100s. Choose a tester that fits your budget and meets your needs. When using an AFCI tester, follow these safety precautions. Firstly, always disconnect the power to the circuit before testing. This will prevent electric shock. Secondly, wear appropriate personal protective equipment, abbreviated PP, such as safety glasses and gloves. Thirdly, follow the manufacturer's instructions carefully. Fourthly, if you are not comfortable testing AFCIs, hire a qualified electrician to do the job. The information provided is intended for general guidance and informational purposes only. It is not a substitute for professional advice from a qualified electrician or electrical engineer. Always consult with a qualified professional before making any decisions about electrical safety or electrical systems. The use of any information provided is at your own risk. The author and publisher are not responsible for any damages or injuries that may result from the use of this information. Electrical work can be dangerous. If you are not qualified to do electrical work, hire a qualified electrician. Always follow all applicable electrical codes and safety regulations. In addition to the specific warning about the Etcon Incorporated AFCI circuit tester, there are other general safety precautions that should be followed when working with electrical systems. Firstly, always disconnect the power to the circuit before working on it. This is the most important safety precaution to prevent electric shock. Secondly, use appropriate personal protective equipment, such as safety glasses, gloves, and insulated tools. Thirdly, never work on electrical systems in wet or damp conditions. Fourthly, be aware of your surroundings and avoid contact with conductive materials such as metal pipes and wet surfaces. Fifthly, if you are not comfortable working on electrical systems, hire a qualified electrician. The National Electrical Code, abbreviated NEC, provides comprehensive guidelines for electrical safety. The NEC is updated every 3 years and covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is essential to be familiar with the NEC and to follow its requirements when working on electrical systems. The Occupational Safety and Health Administration, abbreviated OSHA, also has regulations related to electrical safety. OSHA regulations cover a wide range of topics, including electrical safety training, lockout/tagout procedures, and the use of personal protective equipment. Employers are responsible for ensuring that their employees are trained in electrical safety and follow OSHA regulations. Electrical safety is a critical aspect of workplace safety. Electrical hazards can cause serious injuries, including electric shock, burns, and even death. By following safe work practices and using appropriate safety equipment, it is possible to prevent electrical accidents and create a safer work environment. Regular electrical safety training is essential for all workers who work with or around electrical systems. Training should cover topics such as electrical hazards, safe work practices, and the use of personal protective equipment. Training should be conducted by qualified instructors and should be tailored to the specific hazards and tasks that workers face. Lockout/tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. Lockout/tagout procedures involve disconnecting the power to the equipment and placing a lock and tag on the disconnect switch to prevent it from being turned on accidentally. These procedures are essential for protecting workers from electric shock and other electrical hazards. Grounding is a critical safety measure that helps to protect against electric shock. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and cutting off the power. All electrical equipment should be properly grounded to ensure safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices automatically trip the circuit when the current exceeds a safe level, preventing overheating and potential fires. Overcurrent protection devices should be properly sized and installed to provide adequate protection. Regular maintenance and inspection of electrical systems are essential for preventing electrical hazards. Electrical systems should be inspected periodically to identify potential problems such as damaged wiring, loose connections, and overloaded circuits. Maintenance should be performed regularly to ensure that electrical equipment is functioning properly and safely. In addition to the technical aspects of electrical safety, there are also important behavioral factors to consider. Electrical safety is a mindset that should be adopted by everyone who works with or around electrical systems. It is essential to be aware of the potential hazards and to take appropriate precautions to prevent accidents. Complacency can be a dangerous enemy when it comes to electrical safety. It is important to never become complacent about electrical hazards and to always follow safe work practices, even when performing routine tasks. Communication is also essential for electrical safety. Workers should communicate with each other about potential hazards and should report any unsafe conditions to their supervisor. By working together and communicating effectively, it is possible to create a safer electrical environment. The information provided is intended for general guidance and informational purposes only. It is not a substitute for professional advice from a qualified electrician or electrical engineer. Always consult with a qualified professional before making any decisions about electrical safety or electrical systems. The use of any information provided is at your own risk. The author and publisher are not responsible for any damages or injuries that may result from the use of this information. Electrical work can be dangerous. If you are not qualified to do electrical work, hire a qualified electrician. Always follow all applicable electrical codes and safety regulations. The AFCI circuit tester is a tool used by electricians and other qualified personnel to test the functionality of arc fault circuit interrupters. These devices are safety mechanisms designed to protect electrical circuits from fires caused by arc faults, which are dangerous electrical discharges that can occur due to damaged wiring or faulty connections. The tester simulates an arc fault, allowing the user to verify that the AFCI is functioning correctly and will trip the circuit to prevent a fire. There are different types of AFCI testers available, each with its own features and capabilities. Some testers are designed for specific types of AFCIs, while others are more versatile and can test a wider range of devices. It is important to choose a tester that is appropriate for the type of AFCIs that will be tested. The tester should also be easy to use and provide clear and accurate results. The use of an AFCI circuit tester is a critical part of ensuring electrical safety. By regularly testing AFCIs, it is possible to identify and correct potential problems before they can lead to a fire. This is particularly important in older homes, where the wiring may be more susceptible to damage and arc faults. The UL listing mark is a certification mark that indicates that a product has been tested and certified by Underwriters Laboratories, a recognized leader in product safety testing and certification. The UL mark is a symbol of safety and reliability, and it assures consumers that the product has met rigorous safety standards. The absence of a UL listing mark on an AFCI circuit tester is a serious concern, as it suggests that the product has not been tested to ensure that it is safe and effective. This can pose a significant risk to users, as the tester may not accurately simulate arc faults or may even create a hazard itself. It is always recommended to use UL-listed AFCI circuit testers to ensure safety and reliability. The UL website provides a wealth of information on electrical safety and product certification. The website includes safety tips, product recalls, and information on UL standards and testing procedures. It is a valuable resource for anyone who wants to learn more about electrical safety and how to protect themselves from electrical hazards. Electrical safety is a shared responsibility. Electricians, homeowners, and manufacturers all have a role to play in ensuring that electrical systems are safe and reliable. By working together and following established safety standards, it is possible to prevent electrical accidents and protect lives. The information provided is intended for general guidance and informational purposes only. It is not a substitute for professional advice from a qualified electrician or electrical engineer. Always consult with a qualified professional before making any decisions about electrical safety or electrical systems. The use of any information provided is at your own risk. The author and publisher are not responsible for any damages or injuries that may result from the use of this information. Electrical work can be dangerous. If you are not qualified to do electrical work, hire a qualified electrician. Always follow all applicable electrical codes and safety regulations.